In the last video, we were introduced to general strategies for factoring trinomials of the type ax squared plus bx plus c. Here we have a couple of examples where they are not exactly in that order the way that they're stated. So the best thing to do would be to first put them in that order. What we want to do is use our commutative property to move that y squared to the front. So here's how we'll do that. We'll just rearrange it. Well, this is the same thing as saying y squared plus 10y, because it's a positive 10y, plus 24. And now we can employ the AC method. Remember, we assume that there's a 1 here, and I'm going to be a little bit slavish to this rule at first, but after we get really good at it, you don't need to do all of these steps. You should be able to do them. Recognize when you need to multiply a times c and when you really don't. But since I assume that there's a 1 there, there is a 1 there. That's a very valid assumption. 1 times 24 is 24, so I'm looking for factors of 24 that combine to give me 10. And my factors are 1 and 24, 2 and 12, 3 and 8, and 4 and 6, and that's all of them. Now remember, 10 is positive, so these numbers are positive. And 24 is also positive, so that means that these are the same sign. And so which of these factors, when I add them together, am I going to get 10? 1 plus 24 is 25. No. 2 and 12. Well, if it was 12 minus 2, it would be a positive 10. But they're both positive, so that's 14. That's not going to work. 3 and 8 are 11. Here we go. 4 plus 6. Now let's use that area model, just because I like the area model and I'm going to promote the area model. If you don't like it, well, that's your business. Make sure that you have a good way of doing it. So here's our area model. The first term is going to be my, let's put that in the blue. First term is going to be my y squared. It's this first term up here. Last term, 24, positive 24 goes there. Plus 4x here. Plus 6x, y, sorry, those are y's. Plus 6y here. And it doesn't matter if the 6 is up here and the 4 is down here. You're going to get the same result. So common factors between 4y and y squared are y. Common factors between 6y and 24 are 6. Going down, y squared and 6y is y. 4y and 24 is 4. So this factored out is y plus 6 times the quantity, positive and positive, y plus 4. And if I were to distribute that out and combine my like terms, I would get all of this, just in a different setup. Let's take a look at this second one here. I have 32 plus 4y minus y squared. Now I have a little work to do at the outset. I have to rearrange my terms so that they're in descending order. So that'll be a negative y squared plus a 4y, and then my 32 goes in at the end there. Now this looks a little bit more interesting because there's a negative in front. So that's, now I don't just have a 1 out in front, I have a negative 1 that I'm going to multiply by 32. That's going to change my answer a little bit. One thing we could do is factor out a negative 1, but you really want to be able to use that negative right where it is. And I'm going to show you how to not factor out the negative 1, because when you do your practices in the Khan Academy, it's going to entail that you don't factor that out. So here's how it goes. Take my negative 1, multiply it by my 32, and I get a negative 32. And I need factors of a negative 32 that combine to be a positive 4. Okay, so let's just list the factors of 32, and I know what it is because I can look at it and just, some of you already know what it is, but this is a very good practice, being able to just list factors, and I think I'm done there. Now this bottom number tells me that these are positive. The top number tells me, since it's negative, that these are the opposite signs from those. Because a negative times a positive is a negative. So these are all negative. 32 minus 1 is no. 16 minus 2 is no, but 8 minus 4 is a positive 4. So it's going to be a negative 4 and a positive 8. And let's use our area model. I like that area model. Boy, howdy do I like the area model. Okay, here's how it goes. I create my box. First term is a negative y squared. Last term is a positive 32. Middle terms are negative 4y and a positive 8y. Now here's how I factor them out. They both have a y in common, and they are both negative, so let's make that one a negative y. 8y and 32 have an 8 in common, and those are both positive, so let's make that positive. Y squared and 8y is just the y. Let's leave this positive because in the end I need that to be negative, and a positive times a negative is a negative. 4y and a 32, let's make that a 4. That's what they have in common, and that's positive because my 32 at the end is positive. So this factored, I have negative y plus 8 times the quantity y plus 4. And let's just expand that out. Let's use our crab claw here. I like the crab claw. Negative y times y is my negative y squared. Negative y times a positive 4 gives me a negative 4y. 8y times 8 times y gives me a positive 8y. And 8 times the 4 gives me a positive 32. Crab claw. Negative y squared minus 4y. You owe me $4. You have $8, so you're covered it by $4 and plus 32. Not bad. Your answer then is here. Factored form there. That's the answer. Let's do one more, and I want to use this opportunity to show you why I'm such a fan of the AC method and the area model. Let's take a look at one that says 9a squared plus 18a plus 8. 9a squared plus 18a plus 8. So, factors of 72 that combine to be 18. Okay, let's go. 1 and 72, 2 and 36, 3 and, unless you think I'm doing this in my head, I do have a calculator close by, 3 and 24. 72 divided by 4 is 18. 4 and 18. 72 divided by 5, it doesn't go. 72 divided by 6 is 12. 6 and 12. 7 and nothing at all. 8 and 9, and that's all the factors I can think of 72 that I need to combine to be 18. Okay. Well, look at that. Right there. Right here. 6 plus 12 is 18. Both of them are positive because that's positive. See that? And that's positive because a positive times a positive is a positive. So here is where the area model is super awesome. Let's take a look. Make this one a little bit bigger so it's easier to see. What goes in the first box is this first term here, 9a squared. In the last box is this term here, 8, positive 8, right? In the middle boxes, I have, let's put the 12 up here, 12a, and let's put the 6 here, 6a. Now I use those to define my polynomials. Basically rewriting the polynomial like this: a squared plus 12a plus 6a plus 8. It might be a little more visual if I took these two terms and made them a different color. I like color. Plus 12a plus 6a plus 8. So I did that here in my area model. Now what do? I look for my greatest common factor from my rows and then my columns. So 9 and 12 share a 3, a squared and a share an a. 6a and 8 share a 2. So my first term is 3a plus 2. Going down, 9a squared and 6a also share a 3 and an a. And 12a plus 8 share a 4. So my last term, my last factor, is a 3a plus 4. And I think that is totally factored. Like how I use this area model here to glean out my greatest common factors. 3a times 3a is 9a squared. Plus 12a plus 6a gives me that plus 18a. And 2 times 4 is 8. It would have been the same thing if I'd have come over here and done the, let's see, these share a 3a in common, and I'm left with an a plus 3a plus 4, and then these share a positive 2 in common, and I'm left with a 3a plus 4. These terms share a 3a plus 4 in common, and I'm left with a 3a plus 2. In the next video, we're going to look at some special trinomials and see what makes them special. We're going to use this area model in order to show why we should be able to recognize a couple of these trinomials and factor them in our heads without thinking too hard. That's coming up.